This video is for section 2-8, solving problems. Algebra is used in all kinds of different professions. In high school, we don't have any experience or technical knowledge about those professions, so we can only brush the surface of algebra's real significance. But we have to start somewhere. The textbook starts with simple word problems, and they may or may not have any real-world application. The goal with these kind of problems is to develop the skill of converting word descriptions into algebraic expressions. Once you've developed that skill, you can then apply algebra in any career you choose to go into. Example, the sum of three consecutive even integers is 10 more than twice the smallest of the three integers. Find the largest of these integers. So it's just one sentence, but it's pretty complicated because of all the words that are mentioned. We may need to read this more than once to really pick out what it's talking about. Sum means add. We're adding three numbers. The numbers are described to us. They are consecutive even integers. The word is means equals. We're told it's 10 more than, so that's adding 10 to something. Twice the smallest. Twice means 2 times a number. One technique is to model this with algebra. We know we're looking for three consecutive even integers. Let's use variables to represent them. Let's use the letter x to be the smallest of the even integers. The next even integer would be 2 more than that. The third even integer would be 4 more than the original. These algebraic expressions model the three numbers. Now we can build an equation from the sentence. The word sum means to add them. So let's add all three of our numbers together. The word is the equal symbol. 10 more than means to add 10 to something. Let's read what we're supposed to add 10 to. Twice the smallest of the numbers. The smallest of the numbers was the one we called x, so that's twice x. Here is our equation. If we solve the equation, we will figure out the smallest number. Once we know the smallest number, we can go x plus 4 to get the largest. Let's combine like terms. X plus x plus x is 3x. 2 plus 4 is 6. Next, subtract 2x from both sides. 3x subtract 2x is 1x. On the right side, 2x subtract 2x is nothing. There's still a 10 there. Now subtract 6 from both sides. We get x equals 4. X is the smallest of the integers. We want the largest of them. So put the 4 in right there. 4 plus 4 is 8. This problem didn't have any real-life context to it. Being able to do this kind of math is not important to any kind of job. But it was to illustrate how to apply algebra to a word problem. Here's a summary of the steps that we went through to do this. We might call this a problem-solving plan. Step 1, choose a variable to represent each described number. We chose the letter x to be one of the three integers, and then figured out how to model the others in terms of x. We called the next even x plus 2, and the next even after that x plus 4. Step 2, form an open sentence using facts from the problem. That's when we created the equation by carefully reading each word in the sentence. Step 3, solve the open sentence. That's all of this work here, where we came up with the answer x equals 4. And then step 4, check your result with the requirements stated in the problem. That's very important because finding the answer for x didn't actually answer the question. We wanted the largest of the integers, not the smallest. Here's another example problem. Let's put that 4-step problem-solving plan to work. The base of a triangle has the same length as the side of a square. A second side of the triangle is 1 inch longer than the base. The third side is 5 inches shorter than 3 times the base. If the perimeter of the triangle equals that of the square, find the length of the longest side of the triangle. This problem is about a triangle and a square, So it might help us visualize the problem if we had a diagram. We don't know exactly the shape of the triangle. I'm just drawing a random triangle, and I'm going to draw a random sized square. Let's label the sides with whatever information we can. From the first sentence, the base of the triangle is the same length as the side of a square. Let's call the base of the triangle x. Then the side of the square is x. Because a square has 4 equal sides, all the sides are x on the square. Second sentence, a second side of the triangle is 1 inch longer than the base. So to show 1 inch longer than the base, we write x plus 1. Next sentence, the third side is 5 inches shorter than 3 times the base. How can we show 5 inches shorter than 3 times the base using symbols? 3x minus 5. These pictures can help us to create our open sentence. Let's read farther. If the perimeter of the triangle equals that of the square, find the length. So perimeter is when you add up around the outside. Let's add up around the triangle. 3x minus 5 plus the x plus 1 plus the x. We're told that that is equal to the perimeter of the square. Let's add up around the outside of the square. That will make 4x. That takes care of step 2 of the problem-solving plan, where you take your algebraic expressions and create an open sentence. Step 3 is to solve the open sentence. Let's combine like terms. 3x plus x is 5x. Negative 5 and positive 1 is negative 4. And that equals 4x. Now subtract 4x from both sides. This makes 1x. Minus 4 equals 0. Now add 4. We get x equals 4. The fourth step of the problem-solving plan is to check the answer against the requirements of the problem. What was the problem actually asking us? Find the length of the longest side of the triangle. Well, which of these sides is the longest? Let's find out. If x is 4, then this side is 4. This side is 5. And this side is 3 times 4 minus 5, which is 7. So the longest side is 7 inches. Again, we're not trying to do the kind of algebra that people really do on their jobs. Not at this point in time. Instead, we're simply focusing on taking words and writing them using math expressions. In the question we just did, we drew a diagram to help us visualize those geometric shapes. Other times, making a chart can help you see relationships. Here's an example. Mr. K is 11 times as old as his daughter Talia. 36 years from now, he will be at most twice as old as Talia. At most, how old is Talia? Let's make a chart to help us organize the information. 2 people are referred to. We have Mr. K and Talia. In both cases, we're interested in their age. What is their age now? And what is their age 36 years from now? This creates a table with 4 empty cells in it. Let's put some numerical expressions in those empty cells. The very first sentence says, Mr. K is 11 times as old as his daughter Talia. We don't know how old Talia is. Let's call her age X. Then we can model 11 times as old as 11X. 36 years from now, Talia will be X plus 36 years old. In 36 years, Mr. K will be 11X plus 36. Now let's create an open sentence with this information. The second sentence of the word problem says, in 36 years, Mr. K will be at most twice as old as Talia. That's the clue that we need to create our open sentence. Mr. K's age is at most twice Talia's age. Think about the parts of this open sentence. This expression is Mr. K's age in the future. This symbol represents at most. Being at most is the same thing as saying less than or equal to. This expression is twice Talia's age. Now let's solve this. Do the distributive property. 2 times x is 2x, and 2 times 36 is 72. Next, subtract 2x from both sides. That makes 9x plus 36 is less than or equal to 72. Next, subtract 36 from both sides. 9x is less than or equal to 36. And then divide by 9. We get x is less than or equal to 4. Let's check that result back against the requirements of the problem. We were looking for how old is Talia right now? And we found out that she is at most 4 years old. In that problem, we used a chart to help us organize and see relationships. Other problems use formulas. The formulas might be from geometry, science, finance, etc. Here's an example. At noon, 2 trains leave from towns 200 miles apart. One train averages a speed of 52 miles per hour. The other averages 48 miles per hour. When do they meet? The formula that we're going to use this time is distance equals rate times time, a formula from one of your science classes. Let's figure out the distance traveled by the first train. I'm going to call that D1. Take its rate of speed, 52 miles per hour, and multiply by the time that it travels. We don't know what the time is. Let's call that x. Let's find the distance traveled by train number 2. Take its rate of speed, 48, and times by the time that it travels, x. Now that we've modeled the distances for both trains, we can create an equation from the first sentence, where we're told that the towns are 200 miles apart. The distance traveled by the first train plus the distance traveled by the second train must add up to 200. Now solve the equation. Combine like terms. This makes 100x equals 200. And then divide by 100. X equals 2. The letter X was representing time, and in this problem that's in hours. In 2 hours, the trains will meet. If we had made a diagram, it might have helped to visualize the situation. Here is town number 1, and 200 miles away is town number 2. Train number 1, the faster train, will go more than halfway, while train number 2, the slower train, will go a little bit less than halfway. They will meet each other in 2 hours. A table of useful formulas will be provided for you to use this year. You're strongly encouraged to keep it all year long and write additional formulas on it as you encounter them during assignments. Some problems this year are going to involve angle measures. So here's a quick reminder about some vocabulary from your middle school math class. If you ever see a math problem that talks about complementary angles, those are 2 angles whose measures sum to 90 degrees. For example, 30 degrees and 60 degrees are complementary. Supplementary angles are 2 angles whose measures sum to 180 degrees. For example, 120 and 60. A right angle is an angle whose measure is 90 degrees. It looks like this. A straight angle is an angle whose measure is 180. It looks like this. The sum of the measures of the angles for any polygon can be found with this math formula. The letter S is representing sum, and it was equal to 180 times n minus 2, where the letter n is the number of sides of the polygon. As an example, one polygon is called a hexagon. It has 6 sides. We can find the sum of its interior angles, 180 times 6 minus 2. Figure this out and you get 720 degrees. The sum of the interior angles for any triangle is 180 degrees. And the reason is because when you use that formula, you fill in a 3 because a triangle has 3 sides, and you work this out and the answer is 180. It's certainly worth memorizing that the 3 angles of any triangle add up to 180. Then you don't have to use the formula every time. Let's summarize the lesson. We talked about solving word problems. There's a 4-step problem-solving plan that you can use. The first step is to choose some variables. The second step is to make an equation using the clues that are given to you in the word problem. Step 3, solve your equation. And step 4, check your answer to make sure you've answered what was asked.